Hi, my name is Andrew, and this is Lab 4 for Physics 2. In this lab, we were dropping a magnet down a aluminum foil um, kind of tube, like the ones you get at the grocery store, and measuring how long it takes to fall. The reason behind it is that it will fall slower than if you just drop it on its own, because it produces current, which causes a opposite force towards the motion of the magnet. Um, in the lab, it took 1.29 seconds for the magnet to fall, um, 30.5 centimeters. The magnitude of the dipole moment, or the dipole moment was 3.3. I believe that is it's mass area squared, um, or mass area. Um, no, it's force area. That's what it is. Tesla area. That's what it is. Um, and then the mass of it was 21 grams. This is part of the experiment. As you can see, it takes a long while for the magnet to fall through. And then doing the code, the way we decided to do the code was to basically act as if the aluminum foil was made out of many rings and have the rings spaced out by a little bit, and then measuring how it falling would compare to these rings separated out in space, and then figuring out what the magnitude of their force is based on its velocity as well. Basically calculating flux, then EMF, then current, then force, kind of in that order. The code did predict 0.303 seconds. I believe this is purely a constant error, not a calculation error. It's kind of hard to actually measure aluminum foil because as you move around, it loosens up and kind of fluffs up bigger than what it might actually be. And it probably, some of those measurements are a little off, because I noticed if I change something, it would change the result by a decent margin. So I wouldn't be surprised if the dipole moment was maybe a little off, or the radius was off a little bit, and that causes it to seem like it goes faster. The what ifs. The first one is if the resistivity of the conductor was basically almost zero, how would the magnet falling change? It would change because it would almost not fall, because there's no resistance. Um, Current is voltage divided by resistance. Well, if resistance is zero, basically current is almost infinite, and current's what really matters when you start talking about force being applied. So if there's almost infinite current, there will be a pretty substantial force pushing upwards. It won't counteract velocity, because obviously if you go the other direction, it'll point the other direction. It won't push it up, but it'll basically stop it. And then what if holes or slots were cut into the tube? Basically what would happen is that those little spots, no current can flow, or you kind of say that it has almost infinite resistance or no current. Basically there wouldn't be as much current running through the whole thing, so it would start falling faster instead. Basically, since there's less current, there's less force counteracting, so the magnet will fall faster.